Hello everyone, welcome back to Embedded System course. So we are in practical sessions. So today we are going to study practical number 4. We are going to study development and execution of programs in C for study of logical operators and data conversion. So there are there are two parts in this practical number 4. First, that is study of logical operators, and second, study of data conversion. Okay, that is conversion of data from one number system to other number system. Okay, and vice versa. So for this, we are going to study total 6 programs. Okay, so program number 1, write 8051C program to read the pin number 0 of port 1 and pin number 1 of port 1. Okay, that is pin number 0 and 1 of port 1. We are going to read in, and according to whatever data being inputted on these pins, we have to issue or output an ASCII character on port 0. Okay, as per the following table. So if the data inputted on pin numbers 0 and 1 of port 1 is 00, then we have to send ASCII character 0, that is ASCII code of 0, we have to send to port 0. If that data is 01, we have to send ASCII character 1, that is ASCII code of character 1 to port 0. If that data is 10, we have to send ASCII character 2 to port 0, and if that data is 11, we have to send ASCII character 3 to port 0. Okay, so this is first program. Second program, write a 8051C program to convert packed BCD number 0x39 to equivalent ASCII and display the ASCII bytes on ports P1 and P2. So packed BCD number, concept of packed BCD number we studied while discussing data conversion operations. So what is packed BCD? In a single byte, if two BCD numbers are packed, okay, that number is called as packed BCD. For example, 0x39, this is actually 0x39 means hexadecimal number. Okay, that is 1 byte of data is there. So in this, first nibble is 3 and second nibble is 9. Okay, so this is actually packed BCD number, in which two BCD numbers, that is 3 and 9, the range of BCD number is 0 to 9. Okay, so these two numbers are packed in this single byte, so this number is called as packed BCD. Okay, so we have to convert this packed BCD number to equivalent ASCII codes of each digit in it, that is ASCII code of 3 and ASCII code of 9, that we have to determine, and we have to output these ASCII codes of 3 and 9 to port 1 and port 2. So that is program number 2. The next program, that is program number 3, write a 8051C program to convert ASCII digits 4 and 7 into packed BCD and then display it on port P1. So two ASCII codes are given, or ASCII digits are given, because these are numbers. So which are these ASCII digits? 4 and 7. Okay, so 4 is enclosed in single code, means that becomes a single character, ASCII character. Okay, similarly 7 is enclosed in between single quotes, means this is a single character, ASCII, single ASCII character. So these 4 and 7, okay, so its ASCII codes are different. Okay, ASCII code of 4 and 7 are different. Okay, so we have to, okay, so we have to convert these ASCII digits into packed BCD. Okay, means simply we have to convert this 4 and 7 enclosed in single quotes. Okay, we have to convert it to 0x47. Okay, that is nothing but packed BCD. Okay, and then display it on port 1. Okay, so that is the program number 3. Program number 5, write a 8051C program to calculate checksum byte for the data given as below. Okay, so these data bytes are given 1, 2, 3, 4, 5, and we have to calculate the checksum byte. Okay, so in communication, if you want to send this data, okay, so for um, that is to assure, okay, it's whether that data will be received correctly or not in the at the other end. Okay, one byte is sent with these data bytes in the end, that is called a checksum byte. Okay, so we have to determine the checksum byte. Okay, that will be sent as a last byte with these 5 bytes. Okay, so that at the other end, okay, data integrity can be checked whether this data is good or bad, okay, by using that checksum byte. Okay, so we have to calculate the checksum byte for these 5 bytes of data. And how it is calculated? Just go on adding these bytes and ignoring carries that will get generated. In the end, whatever 1 byte you will get, take its 2's complement, that is nothing but checksum byte. Okay, so we have to process all these 5 bytes accordingly, and we have to determine the checksum byte. Okay, so this is program number 4. Program number 5 is write a 8051C program to perform checksum operation to ensure data integrity of data given. Okay, so same data is given, that is 2276 5E8C99, and in the end there is one more byte. This is actually checksum byte. Okay, so in the end you will receive this checksum byte at other end, and you can check the data integrity of this data received at the other end. Okay, how? You have to just add all these bytes. Okay, so these first 5 are data bytes, and in the end this last byte is checksum byte. So if you add all these bytes together ignoring carries, then in the end, if the sum in the end, if that sum is equal to 0, okay, means that data is good. Okay, if sum is not 0, then that data is byte, means there is an error while receiving this data at the other end, and again this data should be sent. Okay, in this way we can check the data integrity or correctness of data at the other end by using this checksum byte that is sent with these data bytes. Okay, so after checking this integrity of data, display letter G if data is good, and display letter B if data is bad on port 0. Okay, and last program, write a 8051C program to convert binary data 1111 okay, or in hex FDH. Convert this binary or hexadecimal number to decimal equivalent. Okay, and display the digits on port 0, port 1, and port 2. Okay, so these are the 6 programs we are going to study under this practical number 4, that is development and execution of program in a C for study of logical operators and data conversion. Okay, now we will go one by one. So I have already written these programs in project file. Okay, so I will open each program, I will explain, we will run that program. Okay, and we will see the output. Now I have opened this program number 1, which I have already written to save time. Okay, so this is program 1, this is a project file prj4. Okay, so under this program 1.c, this is the prog1.c file in which I have written program. So these are the comments. So whatever followed after double slash, that will be considered as a comment, and that will not be compiled. Okay, so this is the title of this practical number 4, then program 1 title, and then program. Directly we will go to program. I will just minimize this output, build output window. Okay, so this is main program hash include. So what we are going to do, we are going to write a program to read pins of port 1, that is pin 0 and pin 1, and we will issue an ASCII character to port 0 depending on what is data on pin 0 and pin 1. If that data is 00, okay, then we will send ASCII character 0 to port 0. If that data is 01, we will send ASCII character 1. If that data is 10, we will send ASCII character 2, and if that data is 1 1, we will send ASCII character 3 to port 0. So for that program is written. So as usual, hash include reg51.h, then void main void, and here your program starts. Okay, so and here your program ends. Okay, now see here. So first is unsigned char x. I'm declaring x as unsigned char type of variable in which I can store any number in between 0 to 255. Then what I'm doing, x is equal to p1 bitwise AND operator, ampersand, this AND or ampersand. Okay, so this ampersand or AND operator is nothing but bitwise AND operation. It will perform bitwise ANDing operation between the two operands given. So here two operands are whatever data in port 1, and this is a direct data given, that is 0x03. Okay, so what will happen, there will be ANDing operation of whatever data on port 1 and 0x03, that means 0x03 means in binary 0000 and 0011, means actually we are masking all the bits, okay, except the data on port 1 pins 0 and 1, and that is required. We are going to read only data on pins of port 1 0 and 1. Okay, so that's why we are actually masking all other bits and we are taking only whatever data on pins 0 and 1 of port 1. Okay, for that this ending bitwise ending operation I will get. Okay, so whatever value in x, that will either 0 1 2 or 3 depending on what is the data on pin 0 and 1 of port 1. Okay, next while 1. So while 1 means this is infinite loop, means whatever enclosed looping statements inside this while loop, that will be executed infinitely. Okay, now see what is written in this while loop. So switch statement is used. Okay, so switch statement, that is a conditional execution. Okay, so I will explain this switch statement. You have studied this switch statement in a C programming, isn't it? So switch x. Okay, x means whatever value we have read from port 1 pins 0 and 1. So x could be either 0 1 2 or 3, and it depends on what is data on port number 1 pins 0 and 1. Okay, if that data is 00, x will have value 0. If that data is 01, then x will have value 1. If that data is 10, x will have value 2, and if that data is 11, then x will have value 3. Means in x there will be one of the value. Okay, either it will be 0 1 2 or 3. Okay, and accordingly the decision will be taken. Okay, uh, while executing this switch statement. Okay, so inside this switch C, case 0 means if the value in x is 0, it matches with this case and whatever statement under this case. Okay, that is these two statements will be executed. Okay, if value in x is not 0, if it is 1, what will happen, it will come here. Okay, it is matching with this one value and whatever statement underline this case, that will be executed. If value in x is 2, then it will directly come here under that is case 2, and whatever statements under this case 2 will be executed. And if the value in x is 3, it will come here, it matches with this case, and it will execute these statements under this case 3. Okay, now see here, if the value in x is 0, what will happen, it matches with this case value and it will execute these two statements. Okay, so see what these two statements are. P0 is equal to, in single quotes, 0 semi-comma, means what is happening here, we are actually outputting out ASCII character 0 to port 0, because see here, as per program statement, if data on port pins, okay, of port 1 0 and 1 pins, if data is 00, then we have to send ASCII character 0. Okay, if this data is 00, x will have value 0, and then we are actually outputting ASCII character 0 in on port 0, that is whatever asked. After that there is a break statement. Okay, so what this break statement will do, it will break this switch statement, means this break causes to break this switch statement, means after executing this first statement, after After that, break statement will be executed, and due to that, control will come out of this switch loop and go to the statement below this switch statement. And there is no statement below this switch statement. So this is closing brace of infinite while loop, and again this switch statement will be executed. Okay, so probably this statement should be inside. Okay, so inside while here. Okay, so now this is correct. Okay, because every time this while loop will be executed, we have to read whatever data on port 1 pins 0 and 1. Okay, so for that, this statement should be inside this while loop. Okay, in this way, uh, continuously or infinitely we are reading port number 1 pins 0 and 1, and depending on whatever value on these pins 0 0 0 1 1 0 and 1 1. Okay, we are actually outputting these ASCII characters. Okay, if value in X is 1, then what will happen? From here, control will go to this case 1, and then ASCII code of 1 will be outputted to port 0, and due to this break statement, again control will come out of this switch loop, and again these statements, that is X is equal to P1 ampersand 0x03 will be executed, and again this switch statement will be executed. Means this program is continuously monitoring pin 0 and 1 of port 1, and depending on what is there data, okay, what data is being inputted on pin number 0 and 1, decision is being taken to output one of these characters on port 0. Okay, now we will build this program. We will check for errors. So see here, if I press this build, no errors, zero errors. Now I can go for uh, debugging this program. Okay, so now I have to monitor port 0. Okay, port 0 and input, and port 1 pins, that is pin 0 and 1, are used as input pins. Okay, so here I will execute this program. See here, right now this 1 1 is inputted on pin number 0 and 1 of port 1. Okay, now on the port 0, what should be outputted? Here is 1 1, so ASCII code of 3. Okay, that should be outputted on port 0. Now see, now control is here. So first the port 1 will be read, and it will be bitwise uh, uh, ended with 0x03. Okay, all the bits except bit number 0 and 1 are masked, and X will have value 3. Okay, so see, now switch will be executed, so value in X will be 3, so it matches with the last case, that is 3. Okay, so directly from here control will go to this case. Okay, and here port 0, this statement will output ASCII code of 3 to port 0. Okay, that is 33 is the ASCII code of 3 that will be outputted to port 0. 33, that is ASCII code of 3. Okay, now I will change this. I will make 0 1 0 1. Pin number 0 is 1 and pin number 1 is 0. So 0 1, that will if 0 1 is inputted on pin number 0 and 1 of port 1, that will output ASCII code of 1, digit 1 on port 0. Now see what happens. Yes, see here, 31 is the ASCII code of 1. Okay, that will be outputted on port 0. Accordingly, suppose if I now make it 0 0, then ASCII code of 0 will be outputted on port 0, that is 30 is the ASCII code of 0. Okay, now check. See here, 30 is outputted on port 0. Okay, so in this way this program is reading pins 0 and 1 of port 1, and depending on what data is there, it is taking decision to output ASCII codes of digit 0 1 2 and 3. Okay, so this is the first program. Okay, so I think there might no doubts on this program. We can proceed to second program. Okay, so I will stop debug session. Okay, I will remove this program 1, and I have already written second program. Okay, that I will add into this project file. Okay, so I will right click on this add existing. So I will from practical number 4 folder, there is program2.c. I will add this program. I will open it. Okay, so this program 2, what it is, write a 8051C program to convert packed BCD number 0x39 to equivalent ASCII and display the ASCII bytes on ports P1 and P2. Okay, so that means after execution of this program, this on port 1, what should be outputted? ASCII code of 3. Okay, and on port 2, what should be outputted? ASCII code of 9. Okay, that is expected. Okay, so the program is there. Hash include reg51.h void main void, and this is the program. Okay, so unsigned char bcd no. Okay, whatever number bcd number, that is 0x39, we will store in this variable bcd underscore no. Then unsigned char abc, so these are temporary variables of unsigned char that will be used, okay, for the conversion of this bcd number, okay, packed bcd number to equivalent ASCII codes, okay, of digits inside this bcd number, pack bcd number. Okay, now here bcd number 0x39, bcd no is equal to 0x39, means this is the bcd number we are going to convert, okay, to equivalent ASCII codes. So first, see, next statement is a is equal to bcd no, that is 0x39 is uh, bitwise ANDed, that is this is ampersand operator with 0x f0. Okay, means I'm just masking lower nibble. Okay, so ending of this bcd number with data 0x f0, that will mask this 39 number inside this bcd no. Okay, so it will mask this lower nibble 9. Okay, so in a there will be number 0x30 after execution of this statement. Similarly here upper nibble is marked, okay, by ending this bcdno with 0x0f. Okay, so that in b I will have 0x39 0x09. Okay, means I have just separated this upper nibble and lower nibble, or upper bcd number and lower bcd number. In a I will have uh, upper bcd number. Okay, in b I will have lower bcd number. That is, in a I will have 30, and in b I will have 09. Okay, now uh, what I will do, a c is equal to a right shift 4. So whatever number in a मध्ये काय आता सध्या 30. Okay, so we are shifting this 30 4 times towards right, means after shifting data in a 4 times towards right, what data I will have in a, uh, that is 03. Okay, initially it was 30. Due to shifting operation 4 times, that 3 will get shifted to lower nibble, that is 303. Okay, so 03 will be here in a c. Okay, means now I have upper nibble in c and lower nibble in b. In c I will have 03, and in b I will have 09. Okay, then see what I am doing. P1 is equal to c. Okay, p1 is equal to c, and this bar is nothing but bitwise or operator. Okay, so what is the ASCII code of whatever data in c? That is, c is upper digit in this bcd 3. Okay, so what is ASCII code of uh, digit 3? It is 33. Okay, so we have to determine that ASCII code. So for that I am actually bitwise ORing this whatever data in c with 0x30. Okay, so after ORing this data in c, which is 03 with 0x330, what I will get? I will get 0x33. Okay, 0x33 is ASCII code of 3 that I am outputting to port 1. So first task is completed, that is ASCII code of 3, which is 33, I determined, and I have outputted to port 1. Okay, now in b, what is data there? 09. Okay, 09, that is the second digit in bcd number, 09. Okay, so in a second statement, what I am doing, I'm bitwise ORing that data with 0x30 to determine its ASCII code. ASCII code of 9 is 39. If I OR this content of B 09 with uh, I will if I OR content of B which is 09 with 0x30, I will get 0x39, which is ASCII code of 9 that I am outputting to port 2. In this way, after execution of this program on port 1 I will get 33, and on port 2 I will get 39, that is in hex. Okay, which are ASCII codes of 3 and 9. Okay, 3 and 9 digits in the given BCD number, packed BCD number, and that is being asked. We have to convert this 39 packed BCD number to equivalent ASCII codes and display these ASCII codes on port 1 and port 2. Okay, now this program I will build first, so no errors. Now I will go on compiling. Okay, so I will just display port 1 and port 2. So port 1 and port 2 on which these ASCII codes will be displayed. So here control is here. Okay, so I will use step execution in BCD NO variable. I will have that 0x39, that is BCD packed BCD number. Then A, in A, that packed BCD number is bitwise ended with 0xF0. I will get 0x30 in A. Same number if it is uh, bitwise ended with 0x0f, I will get in B what value, 0x09. Then this number in A is shifted 4 times towards right. Due to that, in C I will have 03. Okay, so I will get it. Okay, so okay, so see here internally it is actually happened. Okay, and on uh, port 1, okay, what I have got 33, which is the ASCII code of 3. Okay, ASCII code of 3 is now displayed on port 1, and on port 2 what will get displayed, I will get displayed ASCII code of 9. Okay, that BCD number is in B variable. Okay, so after step execution of this second statement, what I will get here, 3 9 3 9 39. So in this way, this BCD number, okay, packed BCD number consists of two digits, 3 and 9. So ASCII code of 3 is 33, that is displayed on port 1, and ASCII code of 9, that is 39, it is displayed on port. Okay, so if the number is given, okay, if the number is given, so that number, if you bitwise odd with 0x30, I will get its ASCII code. Okay, so this is true with numbers. Okay, not with alphabets. Okay, for alphabets probably the ASCII code starts with 40, we have to check. Okay, so in this way the program performs. So I will stop this program. So we will proceed now to program number 3. Okay, I will remove this program and I will add the third program. I will open it. Okay, so what this third program is, write a 8051C program to convert ASCII digits 4 and 7. So these are ASCII digits. Okay, these are enclosed in single quotes, means these are characters. Okay, so each character is having ASCII code. Okay, so we are calling these as ASCII digits 4 and 7 enclosed in single quotes. We have to convert it into packed BCD. Okay, means in the end, on the after conversion we have to output this packed BCD on port 1, means on port 1 what should be data, 0x47 should be displayed on port 1 in the end after execution of this program. Okay, now see the program, hash include reg51.h void main void. Okay, so this is the program in main function. Okay, so unsigned char BCD byte comma a comma b comma c semi comma. So this statement will declare 4 variables of unsigned char type in which I can store a number in between 0 to 255. So first variable name is BCD byte. Okay, then A, B and C temporary variables. Then the two character ASCII digits characters given are stored in variables X and Y of type unsigned char. Okay, so X is equal to in single quote 4 semicomma means whatever ASCII code of this digit ASCII digit 4 that will get assigned to variable X. Similarly, unsigned char Y is equal to single quote 7 semicomma. This will assign ASCII code of 7 to variable Y. Okay, now next. Now so okay, so first statement is A is equal to X bitwise ended with 0x0f. Okay, means I'm just ending whatever data in X. So what will be an X? In X there will be ASCII code of 4 and ASCII code of 4 is 34. Okay, so that will get ended with 0x0f means upper nibble is masked. Okay, so after execution of this statement, what will be data in A? In A I will have data 04 in hex. Okay, similarly B is equal to Y ampersand 0x0f. Okay, similarly whatever data in Y. Okay, in Y there will be ASCII code of digit 7, that is 37. So that will get bitwise ended with 0x0f means upper nibble will be masked, and in that after ending operation whatever data we will get, that will get assigned to B. So in B I will have 0x07. Okay, so in A I will have 0x04 and in B I will have 0x07. Okay, next what I am doing, I'm just uh, uh, A left shift 4. Okay, so whatever data in A, that is 04, I'm just shifting it 4 bits left. Okay, towards left. Okay, so that 04 in A, that will become 40 and that will get assigned to variable C. Means after execution of this statement in C variable I will have value 0x40. Okay, and then see this statement, BCD byte is equal to C bitwise or operation with B. Okay, in C I have 0x40, in B I have 0x07. So after ORing operation I will get 0x47 and that will get assigned to BCD byte. And 0x47 is nothing but what we are expecting, that is we have converted this ASCII characters 4 and 7. Okay, and we packed. Okay, we have converted this ASCII digits 4 and 7 to equivalent BCD numbers and packed these numbers in a single byte. Okay, because in BCD byte we have now value 47. Okay, that is nothing but packed BCD number. So that number we are outputting to port 1. In this way the program will execute, and in this way the program will convert these two ASCII digits 4 and 7 to packed BCD number 47, and that will be outputted to port 1. Now I will build this so there are no errors. Now I will proceed to debug, start debug session. Okay, so I'm going to monitor port 1 only, isn't it? Because that data is being displayed on port 1. So I will display only port 1. Okay, so in A I will have 04, in B I will have 0x07. Okay, after masking upper nibble. Okay, in X and Y. Okay, so I will in A I will have 0x04, in B I will have 0x07. Then left shift whatever data in A. Okay, and in C I will have 0x40. Okay, it is not displaying. Then in BCD byte I will have, so in C I will have 0x40, in B I'm having 0x07. If both are all together bitwise odd I will get 47. Okay, and that will be outputted on port 1. So port 1 C 47. So this 47 will be outputted on port 1, that is BCD byte, packed BCD byte. Okay, so that will be outputted on port 1. Okay, in this way we can convert the ASCII digits to packed BCD number, two ASCII digits to packed BCD number. We have converted these two ASCII digits, that is 4 and 7, to packed BCD number and outputted that BCD number on port 1, that is here 47. Okay, so in this way this program performs. Okay, okay, now we will proceed towards the fourth program. Okay, so for that I will close this. I will remove this program file and I will add program file number 4. Okay, so this is program file number 4. I will add this. I will open it. Okay, now fourth program is write a 8051C program to calculate checksum byte. So what this checksum byte I have already explained. For the data given as below, so 5 bytes of data is given. We have to calculate the checksum byte from these 5 bytes. Okay, so there is a procedure for this. We have to just go on adding these bytes, 5 bytes, ignoring carries that will get generated while adding these bytes, and after that I will get sum. Okay, total sum in 1 byte, and we have to take its 2's complement, so that will the checksum byte. For that program is written very easy. So hash include reg51.h void main void. This is the main program. Okay, so this is main program between opening and closing braces of this main function. So see here inside this main function, unsigned char data 1. Okay, in single brackets equal to, means I am declaring actually data 1 as a unsigned char type of variable in which these data bytes are stored. Okay, of which checksum byte we have to calculate. Okay, so in data 1 array we are storing 5 elements. Okay, 0x22, 0x76, 0x5e, 0x8c and 0x99. Okay, so first element in this data 1 will be 0x22, second 0x76, so on. That will be stored under the single name data 1 array. Next, I am declaring two variables x and y of unsigned char type. Then, to store the determined or calculated checksum byte, I am declaring a variable having name checksum byte in which I will store the checksum byte calculated. Okay. Then see here y is equal to 0, means y variable is initialized with value 0, and then there is a for statement. For x is equal to 0, x is less than 5, x plus plus. Okay, so x is initialized with value 0. It can go up to maximum 4. Okay, means this loop will be, for loop will be repeated 5 times. Okay, because there are 5 elements in this array that we are going to add in this for loop. Okay, so inside for loop there is only one statement, y is equal to y plus data 1 x. Okay, so first time when this for loop statement executes, what will happen? X is having value 0, so data 1 in square bracket 0 means it is referring to first element, that is 0x22. That will get added to variable y. Initially y is having value 0, so 0 added with 0x22, that is 0x22, that will get assigned to variable y. Now y is having value 0x22. Then x will get incremented by 1. Again this condition will be checked, x is less than 5, still it is true. Again this loop statement, for loop statement will be executed. Right now what will happen? Data 1 in square bracket x is having value 1, so data 1 in square bracket 1 means it is referring to second element, that is 0x76. So that 0x76 will get added into whatever value in y. In y we have value 0x22, that will get added to second element, that is 0x76, and that will be again stored in variable y. In this way, this for statement, what it will do, it will add all these elements in this data 1 array. Okay, and finally when this for loop execution ends, okay, what I have in y, I have addition of all these 5 numbers. Okay, and during the addition all the carries that generated, that we have ignored. Okay, so y will have sum of all these 5 bytes. Okay, even if here 100 bytes are there, okay, if we ignore carry during addition, finally I will have some in a single byte that will fit in a single byte. Okay, so here in Y I have addition of all these 5 bytes, and then I will go for calculation of checksum byte by using this statement. See here, checksum byte is equal to, so Y. Okay, so this is not operator. Tilt is the not operator. It will operate on whatever value in Y. It will take its one's complement. Okay, not operation. And we are adding into 1. If we add 1 into it, then it will become 2's complement operation. Okay, first we are taking complement of Y. So this tilt operator is nothing but not operator or complement operator, and then we are adding 1 into it, means it becomes 2's complement. Okay, so 2's complement of Y is taken, and that will get assigned to checksum byte. Okay, and that we are outputting on port 2. Okay, in this way we can determine checksum byte. Now I will just build this program. Okay, and I will just go in debug session. So on port 1, yes, on port 2 we are displaying that checksum byte. So port 2 checksum byte will be displayed. Now I will directly run this program. Okay, if I directly run this program on port 1, I will get checksum byte. Okay, so that checksum byte is displayed on port 2. Okay, in checksum byte what value is there? So in checksum byte, okay, that is E5. E5 is the checksum byte of the data given. Okay, so these 5 bytes of data given, so that checksum byte is calculated and that is displayed on port 2. So E5 is the checksum byte of this data. Okay, that will be sent with these 5 bytes in the end. Okay, so the actual in communication, serial communication, all these 6 bytes including these 5 bytes of data, and last byte will be this checksum byte, that is E5, will be sent, and in the receiver end by using this 6 bytes, data integrity will be checked. How? At the receiving end all these 6 bytes, so these 5 data bytes and last checksum byte will get added together, and if the sum is 0, then that data is good, otherwise that data is bad, means that data is not correct. Okay, so next program is to check this integrity of data that is received in the end with the checksum byte in the end. Okay, so this is a program number 4. Okay, remaining program we will discuss in second session of this practical number 4. Okay, so I will stop here.